Welcome back to this channel. In today's episode, we're looking at a new topic known as separation techniques of mixtures. Separation techniques of mixtures. In this episode, we'll be discussing the importance or the taking advantages of the characteristics or the individual characteristics of a mixture as to separating them from the mixture. Now let's look at what does it mean by separation techniques. Separation techniques is simply defined as the physical methods available for the removal of constituents from their mixtures. This is defined as the physical processes in removing constituents from a mixture. Now, in a mixture, you get to understand that the constituents still retain their physical and chemical properties. So sometimes it may be very, very needed or very useful for this constituent to be separated and used for a different purposes. So that is the reason why we have to employ different methods of separating these mixtures or this constituent or recovering this constituent. Now, we must understand that first of all, that there are two types of what? There are two types of mixtures. The number one is the heterogeneous mixture, and the number two is the homogeneous mixture. I would have explained this in the previous class or previous episode, but I know that in this episode it is where it will be more explained or better explained. Now let us look at these two types of homogeneous and heterogeneous types of mixture. Now their simple difference is that in heterogeneous mixture, the physical properties of this constituent is not changed. That is to say, their shape and size is still remain the same, even after they have mixed or joined together. While in the homogeneous, their shape and size must have changed. Now let me give you a simple example of a heterogeneous mixture. When you mix sand and water, you get to see that the water or the sand still remain the sand. The sand still remains where it is. Or let me give you another example. When you have a cup of rice mixed with a cup of beans, you see that this is a heterogeneous mixture, because the rice and the beans still retain their physical properties. Talking about the shape, the size, the color, they are still remaining the same. Now, if you look at the homogeneous mixture, you find out that these physical properties have been altered, but that does not make them to become a compound. They are still mixture, because this constituent can still be recovered. Example of a homogeneous mixture. So example of a homogeneous mixture. Let's look at a mixture of salt, water, and sugar, or even just salt and water. You find that the salt has disappeared, is dissolved inside the water. You get to see that the shape and the size and every other thing about the salt inside the sugar or the salt solution has been changed. You cannot visually what differentiate or distinguish between the salt and the water, or sugar and water, or sugar, salt, and water. But in a heterogeneous mixture, you can visually what distinguish between each constituent. Look, another example for a heterogeneous mixture. Let's look at sand and iron filings. You see that the sand is still there. Also, the iron filing is also what there. Another example is okay, good. Another example is your sandwich or your salad, where you have different things put together, different vegetables, tomatoes, and the rest of it mixed together. You get to see that the tomatoes remain the way it is, vegetable remain the way it is, and other stuffs that are being used for the salad is still the way they are. So physically, you can distinguish each constituent. You can visually differentiate them. That is the difference between a heterogeneous mixture and a homogeneous mixture. Now, based on this fact, right, there are methods where we can use to easily or quickly separate the homogeneous constituents, or in a mixture, or the heterogeneous constituent in a mixture. But you must understand that it is very, very easier to separate constituents that are heterogeneously mixed, or than constituents that are homogeneously mixed. So like I said, what I'm saying is it will be easier to separate a heterogeneous mixture than a homogeneous mixture. But in today's study, we want to see each method of separating whether it is a homogeneous or a heterogeneous mixture. Now let me state the types of separation techniques that we have. Now, before I go to each of them, I must state something very clear, that in each of these methods of separation techniques, we must understand the key points of each method, such that we can use with these key points to know which method is suitable for the separation of a particular mixture. If you don't get to know the key points of each of these methods, then at the point of the day, you may not be able to know which method will be suitable for a separation of a particular mixture, whether it is homogeneously mixed or heterogeneously mixed. You must get to know the key point of. Let's look at sieving. Sieving is defined as a process of separating a mixture which contain solid of different sizes. Now, what is the key point of this method? Like we say here, that sieving is defined as a process of separation of a mixture, of separation of a mixture which contains solid of different sizes. Solids of different sizes. Now, the key point here is number one is solids. Number one here is solids. That before you use this method of separation techniques, you must know that the constituent number one must be solids. Solids, number one. Then number two is that they must have different sizes. Whether there are 3 or 4, 2, 3, 4, 5, 6 different types of solids, Another thing you must ensure is that these solids must have what? Different sizes. Now, let me give you a simple example. Let's look at the same what? Rice and what? And beans. If you look at rice and beans, you get to see that what? Both of them are what? Solids. Now, secondly, the rice is smaller than the what? Than the beans. So you can see also that both of them also, they have different what? Sizes. That is to say, when you have rice and beans mixed together, you can easily use the what? Sieving process to separate them from each other. Now, how is sieving being done? Number one, you must ensure that you have a what? A sieve. A sieve. You must have a sieve. A sieve is like it can be a clothing one. It can be something like what's it called? In a metal form. It can easily be made in your houses. After you have gotten a sieve, how do you even get a mesh? You must ensure that the mesh you are making, it will be the size of the smallest what? Particles, or the smallest what? Constituents. I want to make a mesh or a sieve of what? Rice and beans what? Mixture. You see clearly that what? The rice is smaller than the what? The beans. So if I have a tray, for example, I want to make a what? A sieve from this tray. I will make a hole that is what? The mesh will be equal in size as that of the what? The rice. So that as I pour the rice and beans in this what? Tray or in this sieve, only the rice will do what? Will move out of the what? The sieve through the mesh. And then I will now have leftover of what? Beans on the what? Still on the tray, while the rice has been what? Separated, passing through the what? The mesh. So in that way, I'm able to what? Separate rice from the what? Beans. In Africa, especially like, let's assume in Nigeria, they use this method of sieving to separate what? The garri what? In the garri industry. Like I said, the key point for sieving is, number one, the mixture must contain only solids. Only solids. Only solids. And this solid must be of what? Different what? Sizes. I hope that is clear. So let's go to the second method of what? Separation what? Techniques. Decantation. This method is used to separate insoluble solids from a liquid. You see, this method is used to what? To separate insoluble solid from a what? A liquid. Now the key point is that what? Before you use decantation as a separation method for a mixture, you must ensure that what you have, the mixture that you have, contain what? Insoluble what? Solid in a what? In a liquid. Insoluble what? Solid in a liquid. Now, how is this done? This is done by what? Before you carry out decantation, you first of all allow the what? The mixture of what? The insoluble what? Solid and what? The liquid to settle. You leave the mixture for a while such that you have a what? A separation. For example, you have sand and water. I did not say what? Soil. Please take note. I said sand and water. I did not say what? Soil. When you mix sand and water, that means you have a mixture of what? Sand and water. Now, when you put them in a container, you have your sand and water mixed here at the initial time. You cannot differentiate where the sand and water is. They are everywhere. Sand is everywhere, water is everywhere. Then you now leave it for a while. For a few minutes, you get to see that what? You now have a layer of what? Sand and a layer of what? Water. On standing, without shaking and the rest, you just leave it on the table for some time. This is what? After what? After like 5 minutes, after like 10 minutes. After 10 minutes. You will see that what? There will be a separation of what? Sand and what? Water. On standing. You see, then what do you do at the next? You now carry the what? This container containing this mixture, and then do what? You pour out the what? The water out from the what? The mixture. Although this is inaccurate because of the fact that what? You still have some impurities in the what? In the water. What do? You carefully what? Decant. You carefully pour out the what? The upper layer, which is the clear surface, clear part of the water, into another what? Container. Thereby having your water and what? Sand. Apart from the impurity, you will still have some amount of what? Water in the what? In the sand. So clearly, you have not totally what? Separated what? The water from the what? The sand. That is why we say that what? It is inaccurate. But it is also used in a process for what? Separation. It's called what? Decantation. Like I said, before you use this method, you must ensure that the constituent is what? An insoluble solid with what? A liquid. Let's look at magnetic separation. This is used to separate magnetic solids from non-magnetic solids. Now, before you use this method of separation, it's called magnetic what? Separation. Before you use this method, you must understand that what? It is basically used to separate what? Magnetic solid materials from non-magnetic what? Solid material. That means to say that a mixture, it contains what? Both magnetic substances and non-magnetic what? Substances. But remember, both of them must be what? Solids. Solids, not liquid. Solid. Right? And you must understand that what? The constituent or one of the constituents contains a magnetic what? Material. Now, what do? You now use a what? A magnet. You now bring it close to the what? To the mixture, where you have these two what? Mixture. These two constituents. And what happens? The magnetic materials will be attracted by the what? By the magnet, thereby separating the what? The magnetic materials from the non-magnetic what? Materials. That is simply the method known as what? Magnetic what? Separation. With the use of what? Magnet.